Interface concept. General interface in OOPS and here interface are a bit different. Okay, here in what case we use interfaces to avoid primitive inputs to functions. Okay, we declare a type interface. Okay, so our interface use case in OOPS and TypeScript interface use case are a bit different. For example, I'm writing function something like here get so that's get data. So assumption there we have something like name and sal like we have. Okay, so there we are having some logic. Okay, this actually normal format here. So instead of passing individual primitives name and salary, you declare the name and salary inside one interface. So we are just creating as a prototype here. Interface something like person or employee, anything you just take. A new format says do not pass primitives like this. Instead of passing primitives, create one interface and now you take the function and give the parameter as the employee of type employee. Okay, so primitive params are moved into one prototype. That prototype is actually interface and here. Now sometimes we want to pass the name, we don't want to pass the salary. Okay, it may or may not present. Okay, we can make properties as optional. Okay, these are not public static final. Okay, these are like normal properties only here using symbol question mark. Okay, for example, employee, if you want, you can pass department or else leave it. Department, just I'm writing string. X. So how to call this get data function? There's a question. Get data will be called with some input. So what is this input? Input must be an object of name and salary. A direct object creation is possible. No need to write any implementation class. Like this. Okay, you need not write any implementation class. Yeah, we can write like a class also. If you write a class, again constructors, again methods and all additional things required. But interface such things are not required. Even you can just define the optional parameters. Okay, only in the case of some passing like parameters. You have some logic, something like variables, methods and all, then go for the class. Okay, if you want to just declare a prototype for a property that's as an input here, then you can just use it here. To create a prototype, just to pass input to function as object syntax. Then you can just follow here. Okay, instead of passing multiple primitives, this is a good technique. Okay, let me show one small example. Of course, you can write implementation class and all here, but where exactly this is mostly used, I'm showing here in real-time cases. Okay, just I'm creating, observe scenario one, I'm just showing here function result name string salary, it's a number like this I'm writing. There I'm printing the data. I'm just writing return. Name having salary, like this I'm writing. Calling this function result. Okay, this is actually Ajay 500.0 likes. Okay, this is a normal structure. Function is there and just calling this one. Observe. Okay, so here this is going to return the data. Okay, now I'm just again compiling, running. Ajay having salary 500. Now this recommended syntax, look at this recommended format. These two parameters, okay. In case of large number of parameters, two okay, 4, 5, 10, 20, if we have like this, then recommended to keep in interface. Interface. Flex. Even you have something like a department, you can just add it. I just add interface. Now I'm rewriting this function with a parameter employee. Then what we have to do, employee dot name and employee dot salary. Okay, it's a good syntax. Okay, when it is recommended mostly this kind of prototype, there are so many inputs. Like we have 20 inputs are there. Okay, two inputs okay, 20 inputs are there, 30 inputs are there. Instead of writing 30 primitives, create a prototype like this and pass this data. Now the question is how to call this method. Okay, I just want to call this result. Okay, to call the result, we have to create a employee object and pass it. Let employee is equals to an object. Generally, in case of Java, interface objects cannot be created, but here it's possible because they are like prototypes, object prototypes. Directly you can pass the data. No need to write any implementation. And I'm just passing this employee. Salary. So like this I wrote here. See here. Okay. I just want to make sometimes some optional parameters. Department, just I'm mentioning string. Optional parameter. Okay. So here, if the department exists, I want to change the line. If employee dot department exists, okay, else. Okay, return message and just try to let message is equals to empty. Okay, I'm just creating message like this. Okay, if department exists having salary and department is equals to There I'm writing employee dot dep2. If department is not there, because it is optional, department may present, may not present. If it is undefined, if undefined, else block will be executed. If it is defined, this executed. Okay, I'm just passing the department here. Okay, department some dev. Okay, so let us just compile this one and run this one. See, department dev. Let us remove this and try here. I'm removing this value. Else block is executed, like you can see. Okay, so in case of more number of parameters, then recommended to create a prototype called interface and pass it objects. Remember, interface objects directly possible to create here. Okay, this is equivalent to implementation plus object creation. Okay, remember, this is a bit different. It's a prototype syntax. Full example I'm just giving here. Now, like this, I'm writing. Sometimes we are going to use combinations. Look at carefully. Sometimes combination interface are used here. Interface person, I'm just writing here. Person contains name. Okay. There is another interface I'm just writing here. Okay. Uh, employee, assumption employee contains salary. Okay. So that is number. Generally what we write extends person, right? So we can write like this, no issue. Okay. So here, so instead of this one here, okay, just we can create interface student contains fee. Okay, there I'm just writing number. Okay, now we can create a new data type. Okay, just I'm writing here by using type of. Okay, type of. Okay, just I'm writing here. EMP info. I'm just creating with a combination of person and employee. Has to work. Yeah, it's a type, not type of, sorry. Correct. Type of is for casting. So we can create a combination type So with a combination of these two, so if we write implements, we cannot reuse this person here. Just I'm creating one more type, std info, with a combination of person and student. Now I am just writing a function print a, okay, print data. I'm writing here obj. Object can be emp info or student info. Now look at it, can be emp info or student info. If obj instance of emp info it's a type of, this is for primitives. Tensor only it has to work. Emp info. This is correct on just one second. I think this works on this combination. Just one second. So if the salary in object, then I'll take it as a emp info. Else if, okay, here also if we use pipe, it has to work, I think. Yeah, correct. It's signed symbol, right? So if this is fee in object, then it's actually student info. return. So it's a obj dot name employee having salary obj dot salary. Student having obj dot fee is correct. Now we are going to call print emp info is name and second one salary. I'm just calling print here. Okay, this is 15th one, right? There is a predefined method called print that is getting overloaded. I forgot to load and print the data. Okay, you can see it's a employee object. So let us create one more object here for student. It's std of type student info. Student info should not have salary. It should contain fee. I'm just calling the function std, printing the same. Okay, you can see here. So this is a benefit. In case of here, it is a pipe. For example, this is a pipe symbol. Then we can write a type instance of. Okay, that's actually instance of category here. This is example 15. Okay, so mainly for prototype concepts, it is mostly used. You can have multiple inheritance here. So these are all even possible. Interface A, interface B, interface C extends A comma B. Yes, this is possible. No issue. If there is a function, okay, test is there, you can use C type. Then A and B properties combinedly we have to pass here. Okay, you can use as a prototype mostly here. and you can write a interface A, and you can write a class B that implements A. Only single implement is possible. Multiple implementation of interface is not possible. Same like your Java concept. Here also, this is valid. These are even valid also here. Okay. Yesterday session, union types we have seen instance of. See here. This is, I think it's a type of we have seen. Okay. Now here I'm just creating, for example, this time I'll use methods. For example, interface or class, anything you just take. It's an instance of case, right? Okay. There is a customer get data. We have something like this. Okay. Written from customer. Okay. There is a class supplier print data from supplier, like this I wrote. Now I'm just creating a type. Okay. So here provider, I'm just creating a type. Provider can be a customer or supplier. It's not right, it's a type. Okay. So now I'm writing a function. Okay. Print info. P is actually provider. So you can pass either customer or supplier. Now if P instance of customer, else if P instance of supplier, like we are going to use. Okay. Then P dot get data. Here P dot print data. Okay. So it's a print info. We are going to pass something like customer object. I'll pass. Just printing this data. See here. It's a use case of instance. Of course, if it is an interface, there you can just declare abstract methods here and normal variables. That's also fine. Same works. Okay. Example 16. Instance of EX I'm giving this. Okay. So I'll post all these examples as a zip. Already I have posted up to example number 11 previously. You can just check it. To let where constant I have posted, you can just see. Okay, remaining examples also I'll post this one as individual examples. These examples only I'll post. Okay, continuation we see it on Monday class. Thank you.